Hi everybody. This is the first of several videos that are going to introduce you to the Arduino platform. So Arduino is an open source hardware and software platform that is designed for what we call rapid prototyping. It's designed to help students learn how circuit design works. Arduinos end up being used everywhere from grade school all the way through college into professional applications of various kinds. So it's actually not an Arduino, it's an Elegoo. Part of the open sourceness of Arduino means that anybody is free to copy the hardware specifications and manufacture their own. So you'll see this is just a very small circuit board. This one's by Elegoo. Uno R3 here. It's exactly the same as the Arduino Uno. And then over here, I actually have one that I own. This is called the Arduino Mega, and it's just essentially a bigger board with more ports along the bottom. So you'll see they're broadly similar here, the large-sized Arduino versus the sort of standard Uno, and they have, I think, even bigger ones, and I know that they have smaller ones that have even fewer ports. So I wanted to give just a quick tour of sort of the anatomy of the Arduino and a little bit of an overview of some of the things that you will have found in your kit as you're getting started. So the Arduino works by plugging into your computer. It will have come with a USB cable here where one end goes into the computer and the sort of fat squarish end can go right into the Arduino. This cable handles both power and data, sending back and forth through your computer and the Arduino, and it also gives it power through the USB port. The way that Arduino works is a little program that I'll show you. You put the code into the program, or you load up somebody else's code, and you press a button and you send the code over to the Arduino, essentially, and it will run your program. So the Arduino works basically by looping your program over and over and over again, so that once you send a program to this, theoretically you could disconnect it, you could plug it into its power, and you would have a little circuit that runs your instructions. So this makes it highly portable. You'll see Arduinos sort of powering small electronics or art installations or whatever. You can actually use your little gadget separately, although it still needs its own power. So what Arduino lets you do basically is create very simple circuits and then manipulate them with computer code. So a lot of the things that you find in your bag are oriented towards helping you do exactly that. So first thing that you will have found are a bunch of cables here, a bunch of little wires, all different colors, all different lengths. Some of them are very long, some of them are very short. These are all kind of bound together. I think you have to cut the cable ties to sort of get them out. All different colors of wires. Most of them have points at both ends. And so generally what we do is you're going to use these to connect various ports on the Arduino. If you look here on the sides, there are these raised black ports that the wire simply sits in. So anytime you're connecting one port to another, you're basically plugging a wire in from one side to another. Most of them have little labels along here. We've got a couple of them that handle power. If you look really closely, I'm not sure you can quite see it on the camera, but you'll see that one of them is labeled 5 volts, one of them is labeled 3.3 volts. A couple of them are labeled ground. You'll sometimes have circuits that need to be grounded like that. Then we have analog pins over here, which can deal with certain kinds of data, and then digital pins over here, which can deal with certain kinds of data. Then we've got, a large processor, other small little components, and finally a little reset button over here in the corner. On the back, nothing special. So what you do to create some kind of a circuit or some kind of a design in Arduino is generally connecting different ports together through different kinds of wires. So you have your very basic wires here, multicolored. A lot of times by convention, people will use red wires to carry power, black wires for grounding, and then white or colored wires are sort of your data handling wires. Some circuits require all of these things, some circuits don't. You'll see we have various components. This is actually a component that I have that's not exactly the same in your kit. This is a piezo buzzer. This can be used for a couple of different things, including a small speaker. So in your actual kit, you have something that's a little bit fancier. It's a tiny piezo buzzer that's encased in hard plastic. And if you look at it, it'll have a hole in one side where you can sort of see that there's metal inside. And so this essentially is a very, very thin buzzer. You'll encounter this in a lot of different circuits, and when electricity is passed through it, it vibrates very quickly. So it can actually sort of create a musical sound. Here you've got 2 ports. You'll have power on one, data on the other. You'll also have some sensors that actually use 3 ports, where you'll have power, grounding, and then data. So this is actually a proximity sensor. This is something you don't have in your kit, in a basic kit, but most Arduino components can be purchased for, easily under $10, if not under $5 a piece. Some of them are a little fancier. But this one just kind of detects the motion towards something and it transmits data based on that motion. We'll look at how different sensors and inputs work on Arduino later. But all of these, as you can see, have something very similar to the other wires that I showed you. They just have bare exposed wire here that gets plugged into either the Arduino or into what we call a breadboard. So you'll have one of these in your kit. It's just kind of a series of ports all linked together. So a lot of times you will be plugging power or data into one of these, and then you can kind of put in either circuits that need to be connected to each other. You can kind of build things separately on the board. Then you would, have an output going from there, maybe onto another board or something like that. You've got one here. You can go off the board back to the Arduino. These just give you a lot of flexibility to plug a lot of different circuits in. You can connect something else to the breadboard. So everything is basically accomplished by sending signals by these wires. A couple of other things to look at in the introduction of the hardware. Your kit will have several of these. Your kit will have several of these wires, which are wire on one end and a sort of receptor on the other. You can use those either if you ever needed to extend your wires, or you can use those for components that do not have wires attached. I would simply plug this in like that, and you'll need, 3 of them to drive all 3 pins of this dial, for instance. This dial, again, is a separate component, but there's something that's very similar here, a little turning wheel that's called a potentiometer that comes in your kit. A couple of other things that you have in your basic starter kit are buttons here. If you open this small bag, I've got several of these kits lying around, so some of them aren't open yet. If you open the small bag, these are little tiny buttons. You see I can press that. And you see how they have 4 little tiny pins on them. That's what you're going to plug into, for example, your breadboard. You would let it span a couple of different rows here. You can mount that. It's going to send its data, whether it's being pressed or not, through the breadboard. And the Arduino kit also comes with a bunch of little colored plastic pops so that you can say this is the white button, this is the blue button, for example, makes them a little bit easier to press. Finally, something else that you'll see is fuses here. These are resistors. If you look at them closely, they have sort of different values. That's both encoded in their patterns of stripes on the side and also kind of on the tapes that are holding them together. So there's 100, there's 10, 100, or is that 110? Yeah, 10, 100, this is 330, these are 220. And these sort of suppress current. If you want to suppress the amount of current that is going through to your circuit, for example, through to a light, an LED, you would incorporate one of these resistors into the circuit. This can be important if you're building complicated things, if you need to attenuate the signal for some reason, or if you want to, for example, avoid burning out your LED. We'll look at those a little bit, and you get just tons of these all sort of taped together. They're all, I can pull one out here, they're just in two-sided tape. And these just end up going in just like the button did. Just between two aspects of a circuit. They just plug right in. Finally, there are a couple of other assorted sensors and things in here. For instance, this is a light sensor. If you look, if I can focus on the tip here, you see a little zigzag pattern on there. I'm not sure if it's quite in focus, but this is actually a sensor that can gauge the amount of light in a room. So for example, you can cover it up, it's dark, fully lit, or it can sort of tell whether it's in shadow and things like that. Then finally, there are gyroscopes in here that can actually tell. This actually has a moving part in it that can sort of tell if it's being turned on its side or upside down. You can feel it. You can't see it on the camera, obviously, but I can feel that there is a tiny moving piece inside this. And this is used to tell if your Arduino circuit is turned on its side or turned upside down. So this is very similar to what's in your iPhone that sort of tells the phone that it's been turned to the side or turned upwards. This is exactly how that's accomplished, in slightly smaller form inside your phone. So what's cool about Arduino is that it lets you kind of work with circuitry in really interesting ways, kind of getting inside the way that it works. I use Arduinos in a game studies context, number one, because they let us engage directly with frequency, and they let us sort of create music in very rudimentary ways, but I find it to be a really nice simulation of the conditions that early game programmers actually worked under. The people who made things like Pong and, Pac-Man and Space Invaders, and even early Nintendo games were working under variations of these conditions where there was very little distinction, if any, between programming and music. They were essentially programming their game systems or their arcade cabinets to make musical sounds or sound effects in almost the same way as they were programming these consoles and cabinets to actually produce the images, accept the input, and run the game. So I find this to be a really nice unit. It kind of lets you dig in a little bit. It gives you a chance to be a little creative and exploratory, and it lets you see some of the things that early game sound programmers were actually up against. So that's the little introduction to the physical aspects of the Arduino. Next, we'll talk about how to actually send code and programs to the Arduino, and we'll look through the many demonstration programs that it comes with.